Imagine your favorite pizza is made in one tiny shop on the other side of the world. Every time you order, a driver has to set off from that single kitchen, cross oceans and highways, and by the time the box reaches your door, the pizza is stone cold. So the chain gets clever. It opens identical kitchens in every major city, and each one keeps the popular pizzas already hot and ready. Now when you order, the nearest kitchen, just down the road, hands you a fresh slice in minutes, and the original faraway shop barely lifts a finger. Websites face the exact same cold pizza problem with distance, and the fix that prepositions copies near you is called a CDN. Latency isn't abstract. It's the time it takes a packet to travel fiber at 200 km/ms. When users hit your origin server across continents, DNS lookup, TCP handshake, TLS negotiation, and HTTP request all stack up. Worse, every extra router adds jitter and packet loss. A 1-second delay drops conversions by 7%. CDNs are the internet's fast lane. They park copies of your files within 30 to 50 milliseconds of eyeballs. A content delivery network is a globally distributed fleet of edge servers running a reverse proxy like Jinx or Cloudflare's C3 stack, plus a control plane that decides which edge answers each user. Think of it as a delivery service that prepositions your assets in every major metro, so the last mile is a hop, not a flight. DNS redirection. When a user's resolver asks for example.com, the CDN's name servers answer with the IP of the nearest edge pop, not the origin. The trick is authoritative DNS that returns a name to the CDN's Anycast IP, then uses the client's subnet to pick the pop. Anycast routing. The edge pop's IP is announced from every city in the CDN's network. BGP, Border Gateway Protocol, picks the shortest AS path. Packets naturally flow to the closest pop without extra config. Cache key hashing. The CDN hashes the URL plus optional headers, except encoding, user agent, to form a cache key. That key maps to a file chunk. If the chunk is fresh, it's served from RAM in under 2 milliseconds. Cache hierarchy. Each pop has tiered storage: L1 RAM, hot assets; L2 SSD, warm; L3 HDD, or object storage, cold. A miss at L1 triggers a cache fill request back to origin only if the TTL, time to live, has expired or the file is uncacheable. TLS termination at the edge. The pop terminates TLS using a short-lived certificate from Let's Encrypt or a private ACM. The origin only needs to handle traffic from a handful of edge IPs, reducing its load balancer CPU by up to 60%. HTTP/2 and QUIC multiplexing. The edge speaks HTTP/2 to the origin and multiplexes requests over a single TCP connection. QUIC-capable edges can already serve HTTP/3 directly to clients, cutting retransmits on lossy links. Real-time purging. When you update a file, the CDN's API sends an invalidation to all pops within 100 milliseconds. Edge servers mark the cache key stale and fetch the new version on the next request. Edge compute. Some CDNs run serverless functions, Cloudflare workers, AWS Lambda at edge, on the same machines that serve static files. That's how you rewrite headers or inject A/B tests without touching the origin. Take the 2023 FIFA World Cup site. Origin in London. CDN edges in Sao Paulo, Dubai, Tokyo, Los Angeles. A fan in Jakarta hits the URL. DNS resolves to the Jakarta POP. Anycast BGP directs packets to the Singapore POP, closest AS path. The PNG of the trophy is already in the Jakarta edge's RAM because it was requested by 12 million users in the last hour. TTFB, time to first byte, is 14 milliseconds. The origin never sees that request. Myth: CDNs cache everything forever. Reality: TTLs are often 5 minutes for index.html and 1 year for static assets with immutable hashes. Misset TTLs cause stale content or traffic spikes to origin. A CDN doesn't make the internet faster. It short-circuits geography, just like those neighborhood pizza kitchens, keeping a hot copy near every customer. By prepositioning assets and terminating TLS at the edge, it cuts latency from hundreds of milliseconds to single digits, all while offloading up to 95% of origin traffic. If you want the next deep dive into how QUIC actually works or why BGP routing tables have 900,000 entries, subscribe to TechWithJoel. What's the slowest website you've waited for this week? Subscribe to Tech with Joel.